This is lesson 5.1, Translations. Before watching the recording, please make sure you have a graph sheet of paper, a pencil, an appropriate straight edge such as a ruler or even a protractor, and a different colored pen. If you need to get those items, please pause the recording right now. Otherwise, I am going to continue. Just a reminder too, at any point during the recording, if you need to pause or rewind something that you didn't quite catch, please make sure you do that. Now, translations is going to be the first type of transformation we will be examining. Just as a refresher, just remember translations are moving a figure, and please write down whatever I have here on the screen on your sheet of paper too. So translations involve moving a figure right, left, and or up, down. So again, translations involve moving a figure right, left, and or up, down. Now, remember with the translation, the actual size of the figure doesn't change. It's just the location. So on your graph sheet of paper, what I'd like you to do is copy down the XY coordinate grid. Now, because of space limitations, I only went up to 5 on the y-axis and 8 on the x-axis. So please, again, copy this down. Now, A is at 1, 1, just as a point of reference. B is at 1, 3, and C is at 2, 2. If you need to pause the recording again and make sure you jot this down, please go ahead and do so. Now, translations can be given to you in the form of a rule such as this. I'm going to put this in a different color. So the translation rule that we're going to apply to triangle ABC will be R2 up 1. Okay, so what you're going to do is you're going to apply this translation rule of moving each coordinate to the right by 2 and up 1. How do we do that? Well, I'll show you and demonstrate using another color. Let's focus on A first. A is at 1, 1. We want to apply the translation rule of R2U1. Remember that the X, or the horizontal direction, always goes before the Y, or the vertical direction. This should be a review from the first unit when you worked with graphs. Again, A is at 1, 1, so we want to go R2, 1, 2, U1, 1. Now this gets a little bit messy, so I'm just going to say this is the new A. Now, we can't just call it A because it's the translated image. We call it A prime. We put a little 1 on top. It looks like it's an exponent 1, and we refer to it as A prime. Same thing with B. We want to apply the same translation rule. We move it to the right by 2 and up 1, and that is the location of B prime. Okay, C is here. We want to apply R2, U1, and this is C prime. Okay, because it's the image. Now, to make this more distinct, I'm going to connect the points here. And I always like to shade it in a different color so it's distinct from the original. Try not to cover A prime. So this is the location of your triangle, translated R2U1. Now, to make things a bit more clear, I'm going to set up a small t-table here, just inside your graph. Let's redo that line there. Okay, so on the left side, we're going to have the vertices, or the ordered pairs of triangle ABC, and on the right side, we're going to compare it with the vertices of triangle A prime, B prime, and C prime. Remember that original A is at 1, 1. Please make sure you write this in brackets. B is at 1, 3, and C is at 2, 2. Now, A prime, if we look at the location of A prime, it's now at 3, 2. Okay, B prime we see is now at 3, 4, and then C prime is now at 4, 3. There is actually a pattern developing between the coordinates of the original versus the coordinates of the image. It all goes back to what the translation rule is of R2U1. If we look at the x-coordinate of A and we compare it to the x-coordinate of A prime, notice there's a difference of 2 because the difference between 1 and 3 is adding 2. If you look at the y-coordinate of A and the y-coordinate of A prime, you have 1 and 2. It's a difference of adding 1. Therefore, we can conclude that all of the x-coordinates of the original will have to add 2 to get the x-coordinates of the image. We see that's true. If you look at all the x-coordinates here, look at the difference between the x-coordinates here and the x-coordinates of the image. It should be a difference of 2. If we look at all the y-coordinates of the original and the y-coordinates of the image, we should have a difference of 1. We're adding 2 on one side and we're adding 1 on the other side. Why is this important? Is because you should be able to predict the location of a point based on this translation rule after it's translated without actually plotting it on a grid. Now, on the same page or on the other side of your graph paper, please copy down this new XY coordinate grid. Again, because of space limitations, I only went up to 5 on the y-axis and to 8 on the x-axis. You may do the same on your page. If you need to pause the recording again to catch up, please feel free to do so. But I'm going to continue here. So just as a point of reference, let's jot down the coordinates of the original triangle of DEF. Point D is at 8, 4. 8, 4. Point E or vertex E is at 7, 3. And then vertex F is at 8, 2. Now, this time I'm going to present the translation rule in the form of an arrow, and you have to determine what the rule is. In this case, I'm just going to arbitrarily put it out of point F. That's the beginning part of the arrow, and then the end point is right here. I can make that distinct. So what you need to figure out how to do is how do you get from this point to this point? Note in the previous example, which will scroll up here, remember the x direction, the horizontal direction is represented before the y or the vertical direction. So first focus on the horizontal. So are you going right or left? Well, we can see that we're going to the left actually by 2 spaces. Therefore, we can determine that the first part of this translation will be L2. The rest of it, pretty easy. How do you get from here to here? Well, you're going down to 1, 2. So actually, the translation rule is L2, D2, which means you're going to move points D, E, F to the left by 2 and down by 2. What I'd like you to do now is pause the recording and then check your answers once you've finished plotting triangle DEF. Don't forget to label the image appropriately. It is not called triangle DEF once you translate it. Please pause the recording and go ahead and translate triangle DEF. Okay, so the image D prime, E prime, F prime, the triangle of the image should have been and ended up in this location. So we're going to check our vertices to make sure we have the same coordinates. So again, like in the previous example, please just draw up a t-table here. It can be inside your xy coordinate grid. On the left-hand side, we'll have the vertices of triangle DEF. And on the right side, we're going to have the vertices of triangle D prime, E prime, and F prime. Remember original D, and make sure your ordered pairs are in brackets, was at 8, 4. If we compare it with D prime, we see that D prime is at 6, 2. E is at 7, 3. We see that E prime is at 5, 1. F is at 8, 2. Oops. F prime is going to be at 6, 0. Now again, we want to look at the pattern emerging between the coordinates of the original versus the coordinates of the image. So I'm going to take the highlighter. Remember our original translation rule was L2, D2, which means everything was moving left by 2 and down by 2. So we should see a difference of 2 between actually both the x and the y coordinates of the original versus the image. Do we see that? If we look at the x coordinates of the original and we compare it with the x coordinates of the image, 8 minus 6 is 2. Notice it's a difference of 2. How do you get from 8 to 6? It's 2. 7 minus 5 is 2. And 8 minus 6 is 2. If we compare the y coordinates of the original versus the image, 4 minus 2 is 2. 3 minus 1 is 2, and 2 minus 0 is 2. Therefore, we can conclude that left and down are actually negative directions. At the bottom of your page, I'd like you to just jot down a note to remind yourself that when you see positive directions are always going to be right and up, and then negative directions are going to be left and down. This is important to note so that you can predict the location of coordinates without actually having to translate it on an XY coordinate grid. So just remember, what you learned today was how to translate a figure on an XY coordinate grid using coordinates as reference points given the translation rule, such as the example in number 1, and doing the same thing, but also being given a translation arrow and figuring out what the translation rule is from there. Make sure you note what the pattern is so that you are able to predict the location of a point on an XY coordinate grid given a translation rule without actually having to translate it. Positive directions are right and up. Negative directions are left and down. Now, it's a bit of a coincidence that I gave you both negative directions in the example and both positive directions in this example. You would usually have a combination. You'd have a positive and a negative and a positive and a negative, or vice versa. Okay? And that's it.